Hey guys, so today I'm going to try and teach you transcendental functions and integration. So these are just the integrals of ln and e, and make sure you remember your basic integral rules. So remember that ln of x equals 1 over x, and then also remember that 1 over x dx equals ln absolute value of x plus c. And if you're solving using u substitution, then remember that 1 over u du equals ln of u absolute value of u plus c, or du over u equals ln absolute value of u plus c. So for number one, we're using the integral of ln. So the first thing that we're going to do in this problem is we're going to take 4 out of the integral sign. That's because we want to get 1 over x by itself. And so one of the rules was 1 over x equals ln absolute value of x plus c. So that's how we got number 1. We just applied the rule. And then for number 2, in some scenarios you're going to have to use u substitution, like here. So the denominator is going to be u, so that equals 3 minus 6x, and then the derivative of that is going to be negative 6, and then dx equals du over negative 6. So here we're just going to put 4 over u, multiply it by the value of dx, which is du over negative 6, and then we're going to take 4 over negative 6 out of the integral sign, and we get du over u. And that was another one of the rules. It said that if du over u equals ln absolute value of u plus c. So we're just going to apply that rule to here. So yeah, right here, that's what we did. We got ln absolute value of u plus c. And then we just plugged in the value of u at the end. And yeah, that's how we got this answer. Same with number 3. We use u substitution, and u equals x squared plus 4. Derivative of that is 2x, and then dx equals du over 2x. So we put 7x over u, multiply by the value of dx, which is du over 2x. We take the 7 over 2 out of the integral because we want to get 1 over u by itself. And that was another one of the rules where where if you got 1 over u, it equals ln absolute value of u plus c. So you just use that, and then we keep 7 over 2 in the front, and we plug in the value for u. And then, so yeah, that's how we got it, and added c. So that's how we got the answer. And then for number 5, we did the same thing. We found u, find the derivative of u, and then we found dx. We put cos 2x over the u, multiplied it by the value of dx, which equals du over 2 cosine 2x. And then the cosine 2x's, they canceled out. And then we were left with 1 over u times du over u. And then we took the 1/2 out of the integral because we wanted to get 1 over u by itself. And so that was another one of the rule where 1 over u equals ln absolute value of u plus c. So we kept 1/2 in the front, and then did ln over absolute value of u plus c, and we plugged in the value for u. And so that's how we got this answer. So yeah, and then for number 7, it's the same thing, except it's in the square root. So you do the same exact steps as we did up there for these problems. And then for number 8, the u would be the ln. The derivative of ln is 1 over x, because ln equals 1 over x. And then the dx equals x du. So we plug in u for ln of x, we replace it, and then multiply it by the derivative by dx, which is x du. And then the x's cancel out, so these two cancel out, and you're left with u to the power of 4 times du. And then we do the plus 1 over, like you add 1 to the power over the value that you get. So you add 1 to the 1 to the 4, so you get u to the power of 5 over 5 plus c. And then you just plug back in the value for ln, and you get plug back in the value for u, and then you get ln of x to the power of 5 over 5 plus c. So that's what we did for this problem. Okay. So then for this one, here is the integral for e. So the derivative of e to the power of x is e to the power of x. It should follow the rule. It follows the rule that it follows that the rule should be the same for integrals. Okay. So e to the power of x dx equals e to the power of x plus c. And then if you're using u substitution, then e to the power of u dx equals e to the power of u plus c. So for number 13, we're using u substitution, and here u is going to be the power over the e. So u is going to equal 5x. The derivative of 5x is 5. Dx equals du over 5. So yeah, we just replace 5x with u. So you get 4e to the power of u over the value of dx, which is du over 5. We take 4 over 5 out of the integral, and we get 4 over 5 integral sign eu times du, e to the power of u times du. And then we just plug in the value for u, and then we add c at the end, and that's how we got 4 over 5 e to the power of 5x plus c. And then we did the same thing for number 14. U equals the power that is over the e. So u equals x squared. The derivative of x squared is 2x. And then dx equals du over 2x. And so we just replace x squared with u. So we get the integral sign x e to the power of u times du over 2x. The x's will cancel out, so you're left with e to the power of u over du over 2x. And we take the 1/2 out of the integral sign, so we can single out e to the power of u. And so in the end, we just put back in the value for u and add c. So we get 1/2 e to the power of x squared plus c. So yeah, that's how we did that problem. And then for number 16, we did basically the same thing. So u would equal sine x. U would equal sine x. And then the derivative of sine x is cosine x. And then dx equals du over cos x. So we do the integral sign cos x times e to the power of u times du over cosine x, and then the cosine x's, they cancel out, and you're left with e to the power of u times du. And then we just put back in the value for u and add c, so you get e to the power of sine x plus c. And so yeah, this is basically how you solve transcendental functions and integration. If you follow the rules and if you remember them, you'll be able to solve all the problems. And yeah, that's basically how you do it. Okay, bye.